In this task, we will discuss the most popular vector databases currently in use and learn about the differences between vector databases, libraries for generating vectors, and plugins. We will begin with a list of the most popular vector databases currently in use, which are detailed in the description table. One of the best known is FACE, developed by Meta. FACE is a library for efficient similarity search and clustering of dense vectors. It can handle vector sets of any size and provides support for parameter evaluation and tuning. Next, we have Milbus, an open-source vector database capable of managing large vector datasets. Milbus supports multiple search indices and has built-in filtering capabilities. Another database is Quadrant, a vector similarity search engine and vector database that provides a production service complete with an API for utilization. Elasticsearch, another widely recognized platform, is a distributed search and analytics engine that also supports vector fields. It provides support for efficiently indexing and searching vectors. Following Elasticsearch, we have WebAvid, which is an open-source platform that allows for the storage of vector objects and embeddings. We also have the Vespa search engine, a vector database that supports vector search, lexical search, and structured data search. Then we have pgvector, an open-source extension for PostgreSQL that enables storage and querying of vectors within the PostgreSQL database. Finally, we have PyCon, a vector database designed for machine learning applications based on the FACE library. It is fast, scalable, and compatible with various machine learning algorithms. We will now discuss different vector storage systems, as there are not only vector databases but also vector libraries and plugins. We'll start by discussing vector libraries. These libraries create indices that enhance search efficiencies. If you don't want to integrate with a new database, you can use a vector library that creates these indices for you. A vector index typically consists of three components: preprocessing, where you can normalize or reduce the dimensions of the vectors; the main step, which involves an indexing algorithm such as FACE; and post-processing, where you can quantize or hash the vectors to optimize search speed. A library like FACE is sufficient for small, static data. However, vector libraries lack properties that databases have, such as cross-support or disk storage. The index must be completely rebuilt from scratch each time there are changes in the data. The choice between a vector database and a library depends on the frequency of changes in the data and whether you need all the properties of a complete database. On the other hand, there are also databases or search systems that offer vector search plugins like Elasticsearch and pgvector. These plugins usually have fewer features and options for approximate nearest neighbor calculations. Finally, when it comes to vector databases, the decision is based on three key aspects: the amount of data we have, usually in the millions or billions of records for utilizing vector databases, the speed required for queries, and whether all properties of a full database are necessary. If your data is static and you don't frequently update it, you could start by using the vector library. However, if your data changes rapidly, pre-calculating the embeddings and storing them in vector databases for on-demand queries might be more efficient, thus avoiding the real-time computation of vectors and indices. Adding a vector database does involve additional costs and requires learning and integrating an additional system. Therefore, based on the volume of data and the requirements, we may choose a vector database, libraries, or in some cases, plugins.